Here we are on page 9, and we'll finish up the things with regards to the coordinate plane, lines, vectors, planes, and circles that we're doing here. So number 1 through 6, we've got equation of the circle with those following characteristics. Number 1, the center is x negative 2 and 4. That means it's going to have the equation x minus a minus 2, that's plus 2 altogether squared, plus y minus 4 squared equals the radius squared, 49. So this is going to be the circle, and this is actually just a squared plus b squared equals c squared, that grand old Pythagorean theorem. Let's draw that out just so you can make sure we see how this works. We have negative 2, 4 is right up here, and we're drawing all the points out here, x, y, yeah, that have a radius 7. And so you'll see everywhere that's done, we have an x minus a minus 2 and a y minus 4, and we just did this squared plus this squared equals this squared. And that's really all the equation of a circle is. So number 2 has center 3, negative 1. So this is going to be x minus 3 squared plus y plus 1 squared equals radius is 5, so that means this over here will be 25. So radius squared in the middle. Okay, number 3. Center negative 2, 3, so that's x minus a minus 2, that's x plus 2 squared plus y minus 3 squared equals, oh, we don't know, but it does pass through the point 1, negative 4. Now we could do this really quick and say, oh, okay, so this is 3 and this is 7. 3 squared plus 7 squared, that's 9 plus 49 is 58. Square root of 58 is the radius, but we'll notice we re-square it right over there. So it's going to be a 58. Yeah, the radius is square root of 58. And that's the exact same thing that if we would have stuck a 1 in here and a negative 4 right there, that's the number that has to come out. Yeah, this point has to be on the circle, so it has to work. So you can just stick in those numbers right there to get your point. I mean, to get your the number on the other side of the equal sign, the constant that it equals. All right, number 4. Center is negative 4, 3, so it's x plus 4 squared plus y minus 3 squared equals, and yeah, stick in 3, negative 5, and we get 7 squared plus 8 squared, that's 49, plus 64 is 113. All done, and it's squared there. So the radius is square root of 113. All right, number 5. Diameter, endpoints of the diameter. Oh, so we have to find the center. So we have to average these two. So the average of 1 and 13 is 7. So we have x minus 7 squared. Maybe I should write that up. We actually have the center 7, negative 12 and 6. That averages, add those two together, you get negative 6 divided by 2 is a negative 3. So we have x minus 7 squared plus y plus 3 squared equals, and then we've got to stick one of these in. Well, which one? Well, let's check. Stick in 1, negative 12 here, and the distance is 6 and 9. 6 squared plus 9 squared, that's 81 plus 36, that's 117. Okay, good. What if we stuck in the other one? 13 minus 7 is 6 squared, and 6 plus 3 is 9 squared. And so you'll notice 81 and 36 again. Yes, both of these points have to work. If those are the endpoints of the diameter, they better be right. They better both fit in this equation. All right. And the last one, number 6. Endpoints of the diameter. So let's average them. 2 plus 14 divided by 2, that's 8. Negative 11 plus 5, that's a negative 6 divided by 2 is a negative 3. So we get x minus 8 squared plus y plus 3 squared equals, and then let's stick them in, 2 and negative 11. So if we stick this, we get a 6 and 8. 6 squared plus 8 squared, that's 36 plus 64, that's 100. Hey, that radius comes out to be exactly 10. That's pretty cool. Alrighty. So number 7. Ooh, classify each quadrilateral. We're going to need to draw these. So number 7 down here. let's do this. Okay, so we have A at 2, 5. Now I'm going to try to measure these as good as I can, but I might be a little off. B is 3, 9, so it's right here. So this is A, this is B. C is negative 1, 10. So it's like up here. And D is negative 2, 6. So this is a C and this is a D. So let's erase that 7 out of there. There we go. So, ooh, this is looking, I don't know. Do you think that could be a square? It could be, depending on how far off I was. Let's try it. The way we can tell is let's look at these slopes here. We know that from A to B, this is a slope of 1 and 4. Now, do we get the same slope from C to D with a 1 over and 4 down? I mean, yeah, let's see if what we get here. From a C to a D was 1 over and 4. That's right. So these are the same slopes. So these two sides are parallel and they're the same length. You can see 1 squared plus 4 squared equals this length squared. So let's look at it from B to C. It looks like it's a distance of 1 up and 4 over. Is it the same thing from A to D? Yep, we got 5 to 6 and 2 to negative 2, 1 to 4. So you see they're all 1 to 4, 1 to 4, 1 to 4. That means they're parallel and they're the same distance. So so it is indeed a square. Good. Let's try the next one. Number 8. Let's see what we get here. So A is 3, 5, and B is 7, 7. So A, B. C is 1, 9. And D is negative 5, 6. So let's check and see with our slope. That'll give us our distance. So from A to B, it's a run of 7 minus 3 is 4 to 2. It's a 4 to 2. And let's check from B to C. B to C is we're running up 2, but backwards 6. Is that right? Yeah, 6. That's interesting. A 2 to 6 ratio there. Okay, C to D is 1 to negative 5. That's a 6. And 9 down to 6 is a 3. Oh, now that's interesting. Look at this. This guy has the same slope as that one, but they're not the same length. Okay, and then let's try D to A. Negative 5 up to 3, that's an 8. And 5 to 6 is a 1. Oh boy, so these guys are not parallel at all. But these guys are parallel, but they're not the same distance. So that means we have a trapezoid. That this guy right here and that guy right there, yeah, they're parallel. Let's put those arrows on it. But these two are not. So we have a trapezoid. Trapezoid. All right, the next one. Let's try number 9. So let's put these guys in the graph. 2, 5, 7, negative 4. Ooh, there's B down there. 7, negative 4. And then C is negative 1, 10. Whoa, clear up here. Okay, and that's C. And then D is negative 3, 6. So like here. Oh boy. A, B, C, D. Well, let's see what we get here. Is it possible that this guy right here and these guys right here? Ooh, yeah, I don't know what that's going to look like. Let's check it out. Okay, so from A to B, what's that slope? we're going up 5 and down 9. So up 5 and down 9. Okay, what about from A to C, or from B to C? 7 to -1, that's subtracting 8. Yeah, let's go like this. And, subtracting 8, and the y value is going up 14. Okay, from B to D, from C to D is -1 to -3 is 2, and from 10 down to 6 is 4. I'm not seeing a lot of stuff happening here. And then from D to B is -3 up to 7 is 10, and -4 up to 6 is 10. Oh boy. What about from A to D? Yeah, I don't think we're getting anything. I don't think we have anything here. Nothing special. So we're not getting parallel lines or same distances. All right, number 10. All right, where's A? A is at -2, 5. We'll put that guy right there as an A. B is at 3 and then up 9. C is at 11 and then -1. And then D is at 6 and a -5. Oh, this looks kind of promising. I don't know how good my drawing is, but let's find out here. So from A to B, A goes from -2 to 3, so that's a distance of 5 horizontally, and from 5 to 9 is 4 vertically. Okay, now B over to C is 3 to 11 is 8, and 9 down to -1 is 10. So this is a -10/8, and that's a positive 4/5. Those guys are perpendicular. So this is looking like we're making a rectangle, but let's just double check that, shall we? From D to C would go from 6 up to 11, that's a 5. And from -5 to -1, that's a 4. Good. Yep, these two are indeed parallel, and it's a 90-degree angle as well. I don't even think we need to check A to D, but we will anyway. -2 up to 6, that's an 8. And then the vertical is from -5 to 5 is a 10. Yep, indeed, we have a rectangle. Oh, good. I'm glad we got one of each of them. Trapezoid, square, rectangle. Alrighty, good. Let's get some of this stuff out of the way and move on. Number 11, what angle has a terminal side that contains the point 3, -1? So if we look, number 11 right up here, where the point 3, -1 is. So over 3, down 1. So we're talking about this angle right here. And the angle that we're looking at for a terminal side is this guy. So almost 360 degrees. Let's pull out our calculator and see what we get. We know that we're out 3 and down 1. So we can take the inverse tangent. If we do tangent of theta equals 1/3, we'll know what this guy is in here. So let's go ahead and pull that guy out and do second tangent of 1/3. That's 18 degrees. So we are just shy of 360 degrees by 18. So subtract that from 360. So I did that backwards. So it's a positive 341 degrees, 341.6. 341.6. The terminal side of 341.6 is right down here on 3,1. All right, next one. Terminal that has 2, -4. So 2 down, -4. So here's 2. Here's -4. So we'd write the tangent of theta equals opposite 4 over 2. So let's plug that in and get tangent inverse of 2. In turn, we get 63 degrees. Subtract that from 360. Again, I am subtracting backwards, so the answer is actually the opposite of this, 296.6. 296.6, and we're in degrees. Make sure that in your calculator you know whether you're doing radians or degrees, and we're staying in degrees for this exercise here. The next one, number 13, looks a little bit different. We've got, this time we're at -2, 5 is up here. And so if we drew our little triangle, we have a 2 and a 5 there. Here's our theta. So tangent of theta equals 5 over 2. Let's figure out what that one is. Inverse tangent of 5 over 2. And we get 68. But notice, on this angle, we're measuring this guy right here. We're not coming around all the way to 360. We're taking it from, this needs to subtract from 180. So we're going to subtract 180. Note that we are subtracting backwards. So we now have 111.8. Good. Number 14. What angle has a terminal side? The needs 0.73. So we're out 7, up 3. So this one, it's just good. Hey, whatever the calculator gives us will be it. We're out 7, up 3. So we're going to take tangent of theta is opposite over adjacent. That's second tangent of 3 divided by 7. Enter. 23.2. Starting with number 15, we'll draw 15 out, even though we won't need to do this on all of them, but we'll be able to show you what's going on with each of these. So 15, it's 2i plus 3j, which is right up here. It's just 2, 3. And you'll notice we're going to get this theta again. Now we need to double check and make sure we're in the right quadrant, but 2, 3, we're going to use Pythagorean Theorem. So the magnitude of 15 is going to be 4 plus 9, 2 squared, plus 3 squared equals c squared. Boy, we use that guy a lot. 4 plus 9 is 13. So the magnitude is the square root of 13. And the direction, we're going to be tangent of theta equals 3 over 2. So on all of these, we'll be taking that number over that number and finding out the angle that we need to have. So tangent inverse of 3 over 2. And that gives us 56 degrees and 56.3 degrees. Good. All right, number 16. We're going to take the magnitude is going to be 3 squared plus 7 squared and then square root it. That's the magnitude, and so we get 9 plus 49 is 58. So this guy's going to be the square root of 58 big. And to find out the angle, we're at -3, 7. So again, we're going to be just over, let's do that, -3, 7. We're going to be over, subtracting it from 180 degrees. We're going to be more than 90. 7 divided by 3, and do the inverse tangent of that particular answer. And we get 66.8 degrees. 66.8 degrees. All right, the next one, 21. Notice where this guy is. 2 minus 9, we're going to be way down here with a 2 and a 9. So if we get the theta, we've got to subtract it from 360. So tangent inverse of 9 halves. So we're at 77. We're going to subtract that from 360. And we're at 282.5 degrees. 282.5 degrees. Now the magnitude, notice 2 squared plus 9 squared equals this distance squared. So 4 plus 81, that's 85, square root of 85. So that's the magnitude of that vector. Number 18, we are at, -3, -8. So we're at -3, -8. So if we look at this angle, when we get tangent of theta equals 8 over 3, we need to make sure that we are going 180 degrees, and then whatever number we get there is going to put us down in this quadrant. So tangent inverse of 8 over 3. 69. Now notice, so we're 180 plus this 69 degrees. So now let's add to 180, and it's 249 degrees. 249.4 degrees. Okay, and the magnitude, we get 3 squared plus 8 squared equals the distance squared. 9 plus 64 is 73. So we are the square root of 73. That's the magnitude of that vector. Number 19, 2, -1. And the only reason they're written differently is so that you as a student can get used to seeing the vectors in these different notations. So we're at 2, -1. Good. So tangent of theta is going to be 1 over 2. Plug that in. Inverse tangent of 0.5. And we get 26.56. But where is it? We're going just shy of 360. So we need to subtract that from 360. We're subtracting backwards, so we'll get the opposite. And we get that 333.4. 333.4 degrees. And the magnitude, 2 squared plus 1 squared equals the distance squared. That's 5. Yeah, square root of 5, 4 plus 1. So it's the square root of 5. Good. Number 20, we have 5, 17. So we're 5, 17, right up there. Wow, almost 90 degrees there. So we have a 5 and a 17. So let's do inverse tangent. Let me see, tangent of theta. Let's write this out right. Opposite over adjacent. So we take 17 divided by 5 and the inverse tangent of that. We get 73.6. So that is our angle, 73.6, because we're just coming up exactly that theta. But what about the magnitude? 5 squared plus 17 squared equals distance squared. That gives us 25 plus 289, that's 314. Square root is our distance. Does that come out nice? I don't think we can take out. You see 2 and 157. Yep, I don't think so. So square root of 314. Okay, next guy. Number 21, -3, -5. So notice we're down here bigger than 180 degrees. So when we get this theta of it's 3 over -3 and down 5. So when we do tangent of theta equals 5 over 3, just remember we've got to add that to 180. So we do second tangent of 5 over 3. Enter, we get 59.06. But we're clear down here past 180, so we add 180 to it, and we get 239 degrees. So we're at 239, and then we've got to do the square root of, we have 3 squared plus 5 squared equals the distance squared. So we get 9 plus 25 is 34, d squared, and then we square root. Good. So square root of 34. And the final one, number 22. We are at -4, 1. Oh, -4, 1. We're up here in the second quadrant with a -4 and then a 1. So there's our little theta. So we got tangent of theta equals 1/4. Now we got to remember we're just shy of 180 degrees, this amount. So when we put it in, we do tangent inverse of 1/4. That we have to subtract that from 180. I'm subtracting backwards, so I will get the negative number of the true answer, which is 165.9, 166. So 166 degrees. And this is 4 squared plus 1 squared equals your distance squared, that magnitude of the vector. 16 plus 1 is 17, and we square root it, so the square root of 17. Okay, good. Let's get some space again. Number 27, it says write the parametric equations of the line. So that means we need something like x equals mt plus where we start with x naught, and y equals some other slope, so of t plus x naught, and z is going to be some other slope, third slope plus x naught, and this is our parameter. That's why they're called parametric equations, a parameter. Good. So this is how it works. We're starting at a point 5, 0, 2. And I'm going to graph this sort of. It's not going to be a real graph, but we're starting at this point 5, 0, -2 out in the middle of the boonies somewhere, and we're headed off on a line somewhere, and it's headed in the direction 2, -1, 3. So that means the x increases 2. So the next point on this line is 7, -1, and then this went up 3 to 1. And then the next point means it goes up to 9. This goes down to -2. And then this guy goes from -2 to 1 up to 4. So I just followed this vector, that direction from that point, and you'll see it just makes stops every so often. So that's how we write the parametric form of this line. We can only have one free variable because it's going to be a one-dimensional line, even though it's in a three-dimensional space. So this is how it works. The x is going to start at 5, and then it goes up 2 for every parameter t, and we just stick different variables in for t, like this is when t would equal 1, and this is when t would equal 2. So 5 plus 2t, or if you wanted to write it like this, 2t plus 5, that's fine. Then y would equal 0 minus 1t, and then z would equal -2 plus 3t. And so if we stick in t equals 0, we get our starting point. If we stick in t equals 1, we get that point. If we stick in t as -1, we'll get a point down here. If we stick in t as a half, or t is 1.7, so every point on this line corresponds with a value of t. And that's a parametric form of equation. So that's kind of cool. That is how we would write an equation of a line in three-dimensional space. With that background, you'll see most of these are pretty nice and easy. X is going to start at 3, and it's going to increase by 5 for every value of our parameter t. Y starts at 4 and goes up by 17 each time, and z starts at -5 and goes up, down. Let me go back on that one. Goes down by 3 for every one of them. And if you stick in t as 1, 2, 3, 4, 8, 10, 12, yeah, you would get different points on this line. You should also note that we could have started with this point and on number 27 and gone this vector. That would just be starting up here and going off in that direction. Sure. And then you'd go backwards, and this guy would be where t is -2. These parametric equations are not unique. In other words, there may be very many different versions of it to get that same equation. All right, so this one, x equals 5 minus 3t, that is starting there and then going that direction. Y starts with -3 and goes down 5 for every t, and then z starts at 6 and goes up by 6 for every value of t we choose to put in. All right, and the last one, we start at, let's write it out a little bit different so you can see what we're doing. When t is 0, we want the point 4, -3, 1. And when the point is 1, when we stick in t as 1, we want it to have gone -4 in the x direction, plus 1 in the y direction, and 8 in the z direction. So that's our slope, our individual slopes there. Plus a -4t. Oh, didn't want that plus. 4 minus 4t, plus 1t, and plus 8t. And that will ensure that we are heading in the right direction. So this is like our slope vector right here. And this is like our y equals mx. This is our variable that goes in plus our original starting point, b. Okay, so number 31. Here we're going to write an equation of a plane that is perpendicular to each vector. So we've got something like this happening. So the vector in this case, 2, 1, -1, 3, and the point 5, 0, negative 2. So you'll notice we're using the same problems, but we're not writing the equation of that line going up through there. We're writing an equation of the plane. Yeah, so this one turns out to be a very slick way of doing it. You have 2x minus y plus 3z equals, and then we stick in the point to see what we get. If we stick in 5, we get 10 minus 0 minus 6. That's a 4. And we're all done. That's amazing. Now, the reason that this works is that the slope right here is perpendicular. This vector is exactly perpendicular to this entire plane. And it goes into some calculus, and when you cross product any vectors in this plane at all, you will end up being perpendicular to it. So that's actually where this comes from. But the shortcut, it's kind of nice connection. Back in lines, when we had a slope of 2/3, this actually meant, now you notice we could write an equation 2x minus 3y equals something. Watch what I do if I change this into a vector format. 2/3 means the rise is 2 and the run is 3. And you're like, oh, how does that help? That doesn't look at all. Notice what the perpendicular slope is. The perpendicular slope would be slope is negative 3 halves, which if I wrote it in vector form would be a negative 3 on the y and a 2 on the x. So the perpendicular slope in vector form, these guys turn out to be exactly the coefficients in front of the x and the y. So it's kind of actually a three-dimensional extension of our shortcut to the standard form of an equation of a line. So with that in mind, we should be able to go through these fairly quickly. We're going perpendicular to the direction 5, 17, negative 3. So that's the whole plane. We're going to have a 5x plus a 17y minus a 3z equals, stick a 3 in there, and we get 15 plus 68 is 83 plus 15 is 98. And that's it. All we did was stick the 3 there, the 4 there, and the negative 5 there to see what point had to come out. The next one, number 33. We're going in the direction of negative 3, so negative 3x minus 5y plus 6z. I mean, we're going perpendicular to this direction, so that's our direction headed up there, and we're looking at this whole plane that is normal, perpendicular in every direction to that, equals, and we stick in 5, negative 3, 6. So we get negative 15 plus 15 goes away, equals 36. Yeah. And the final one. Let's go. Okay, negative 4x plus y plus 8z equals, and then let's stick in the 4, negative 3, and the negative 1. So negative 16 minus 3 is negative 19, minus 8 is a negative 27. And there we have it. All right, we're going to need some space for these next ones. And now, numbers 35 through 37, we're going to find the distance from the point to the plane. So we've got a point out here, and we've got to come in perpendicular to get that distance, find that point that intersects, and with doing that, we'll be able to find these 2 points and get their distance between them using a squared plus b squared plus c squared equals d squared. And that's what is that is the distance in 3 dimensions. So let's do it. Number 35. So we're on this point 4, negative 3, 6. Let's write that down. Negative 3, 6. And we're coming in at the slope vector of 3, 4, negative 2. And we just pulled that straight off of the A, B, C coefficients. This is the vector that is perpendicular to the whole plane. So that means this line has the following equations in parametric form. X equals 4 plus 3t. Notice we just picked this 4 and then we're going in that direction. The y is going to be negative 3 plus 4t, and the z is going to be 6 minus 2t. So we just picked 4, negative 3, 6. That's our starting point, and then here's our slope vector. And they're kind of all in the mx plus b type format. All right, now let's figure out which t will make this line cross the plane exactly. So we're going to write out this equation. 3x, that's 4 plus 3t, plus 4y, that's negative 3 plus 4t, minus 2z, which is 6 minus 2t, and this all has to equal 17. All right, let's do it. And we're going to get 12 plus 9t minus 12 plus 16t as we jump the 4 in, and then jump that minus 2 in, and we get negative 12 plus 4t equals 17. Combining like terms, those 12s cancel, and we get 9 plus 16 is 25 plus 4t, that's 29t. And then, what do the numbers equal? That's, minus 12 adds over to that side, and we get 29. Oh, look at that, t equals 1. So when we place t equals 1 into here, that means we started at that point off, and at t equals 1, we are now dead on the plane. So at t equals 1, we get the point x equals 4 plus 3 times 1 is 7. Y equals negative 3 plus 4, that's 1. And then 6 minus 2 times 1, so that is 4. The point 714, and you can try that. Stick 714 in there, and it will equal 17. So now what we need to do is find the distance between these 2 points, which we're going to get by 4 to 7, that's 3 squared. 3 negative 3 up there is 4 squared. And 6 to 4 is 2 squared, and then we're going to square root all of that. It's the Pythagorean theorem, but in 3 dimensions. A squared plus b squared plus c squared, and then square root it. And we get 9 plus 16 is 25, plus 4 is 29. Square root of 29, and that's the answer to number 35, square root of 29. All right, let's do number 36. We start off with the point 9, negative 2, negative 9. So that's the point off up here. And now the vector that we're supposed to follow is the negative 2, 5, 3. Negative 2, 5, 3. So this is the direction. The x will always go down by 2, the y goes up by 5, and the z goes up by 3 to the very next integer point that we have. All right, so let's write the equation. So we have x equals z. I'll write this a little bit differently so we can see it. 9, negative 2, negative 9. So that's where we're going to start. And then for every t, every step in our parameter, we're going to go down 2, up 5, and up 3. So the x, the y, the z component there. Yeah, there we have it. So now let's stick these into the equation of the plane. So we get negative 2 times the x, that's 9 minus 2t. Plus 5y, and the y is negative 2 plus 5t, and z, so we get plus 3z, which is negative 9 plus 3t. That has to all come out to equal 21. All right, let's do it. This is back to a nice equation in one variable that we can handle. That's negative 18 plus 4t minus 10 plus 25t. Minus 27 plus 9t, all has to equal 21. And let me see, what do we get here? And let's see, we have a 4t and a 25t and a 9t. That's 38t. Negative 18, negative 10, that's negative 28. And negative 27 is a negative 55 equals 21. So if we add 55 over there, we get 38t equals 76. Divide by 38, and t equals 2. Aha, so at t equals 2, this x, y, and z, where are we on the line? Well, 9 minus 4, that's 5. Negative 2 plus 10, that's 8. And negative 9 plus 6 is a negative 3. So this point is on the line at t equals 2. This point's on the line at t equals 0, but at t equals 2, the line has come down. So there would be like t equals 1, there like t equals 2, and it hits it right there, and it's on the plane as well. So we need to find the distance between these 2 points. So 9 down to 5 is 4. So we're going to do 4 squared plus the distance between those two is 10 squared, and then -9 to -3 is 6 squared. So the square root of a squared plus b squared plus c squared, and we get 16 plus 100 plus 36. That's 152 square root. I think we can simplify that just a little bit. This is 38, it appears. Yeah, 38 times 4, 4 times 38. So square root that, and we get 2 square roots of 38. And that's our answer down here, 2 square roots of 38. Good. And for 37, here we have the point 32, -11, -11. That's the point we're going to start with. And we're going to go the vector direction, 7, -4, -2. Good deal. So that's x equals 32 plus 7t. Y equals -11 minus 4t. And z is -11 minus 2t. Okay, let's do it. Stick these guys into the actual plane formula, and we'll find out where this line anywhere along here. So we've got this point up here, and we've got this direction. So we stick this guy in to see where we're going to intersect. So we have 7 times 32 plus 7t minus 4 times -11 minus 4t minus 2 times -11 minus 2t. And that all equals positive 14. Okay, so jump that in, that's 224 plus 49t plus 44 plus 16t plus 22 plus 4t equals 14. Okay, collect like terms. 49 and 16 and 4 is 69t. 224 plus 44 is 268 plus 22 is 290. That equals 14. So subtract 290 and we get 69t equals -276. When we divide by 69, I hope this comes out close to being right. Let's put a calculator up there. -276 divided by 69. And it does. It's going to be a -4. So t equals a -4. All right, with t equaling -4, that means we now can write out what our x, our y, and our z are in that special place that's right on the plane. 32 minus 28 is 4. -11 plus 16 is a 5. And -11 plus 8 is 3, -3. Is that right? Let's do that one more time just to make sure. 32 minus 28 is 4. -11 plus 16 is a positive 5, and -11 plus 8 is a -3. So 4, 5, -3, that's the point. So let's do this now to find the distance between that point and that point. So 32 down to 4, that's 28 squared plus, then we've got -11 to 5 is 16, and then we have -11 to -3, and that's an 8. So 8 squared. So we've got to take the square root of 28 squared plus 16 squared plus 8 squared. I'm going to need a calculator for that. 28 squared plus 16 squared plus 8 squared, and that equals 1104. So square root of 1104. Is 1104 going to be able to, let's see if it divides, 4 goes into it. Oh, look at that. Oh, look at that, even further. So we can divide by 4 6 times. So 1104 is the same as 4, yeah, 16 times 69. Square root that and we get 4 square roots of 69. Excellent. 4 square roots of 69. And there we go. Good.